Okay, what about this now? How is
it now?
How is it now? Is anyone texting? Okay.
No.
Okay.
No,
now we can.
can.
Okay, good. Thank you. Okay, thank you for telling us. So we have a lot of data, and we need to classify this data and organize it to organize our documents, organize our tweets, organize our data. So text classification is one of the most fundamental subjects in NLP and machine learning. And from this, actually, most of you here waiting to do that and to learn about this, to do sentiment analysis, emotion detection, topic modeling. So So for emotions, you can see it from like face movement and movements. You can have emotions using from the voices or from written language. In this lecture, we only focus on emotions and written language. So basic emotions, there's a lot of psychology people who are working on defining emotions. So Paul Ekman in 1970s, he was one of the psychologists that work on defining emotions. He identified emotions to be, oh, nice. That's good. Okay. Thank you. And we have messages here. Okay. So, so there is like 6 basic emotions that Paul Ekman wrote about it, like in his published papers, like happiness, sadness, angry, disgust, surprise, and fear. And he later added more and more, and he added like another 5. So there is like this diagram about emotions. And you can see, like, if you combine 2 different emotions together, you will have another emotion. So love comes from this and this, or anticipate is coming from this emotion and this emotion. So yeah, here we have we have like a lot of psychology who worked on defining emotions. In my research work, I worked only on 11 emotions. So people work on more than 11. Okay, they are still working on the voice. Like they have ego.
Maybe they should try to copy. Ya da design sesini kıssana. Mute'un oradaki ses aşağı doğru.
About this now. So no mic. Okay.
No, there's mic. There is audio coming out of the computer. Audio. If there is.
Okay. So
There's no audio.
okay.
No, there is audio on the Zoom.
I hope like the online people here are good with the voice and with the presentation. So what is the difference between sentiments and emotions? Okay, this like seems it comes from here. So to talk about sentiments and emotion. Sentiments is about opinions. So you need to know what's people's opinions about something. Are they with or against something? This is sentiments. Okay. So sentiments are actually there's some difference between sentiments and opinions actually, but sentiments is about to have like positivity or negativity about your opinion. So if you say that the weather is good today, it is positive sentiments. If you say that the weather is not okay, it is like it is sunny, but I hate sunny weathers, it is negative sentiments. And if you say only like the fact that it is today it's 30 degrees, it is only neutral. So this is like when you are trying to analyze people's sentiments about some, let's say, some decisions, if they are with or against, let's say, Donald Trump, like you will say that this is like they are positivity toward Donald or negative toward Trump. But for emotions, you try to figure out, like, even if they are positive with Donald Trump, maybe they are joy, they are angry because they are angry for him, not because of him. They are angry for him, or they fear that they are gonna play with the elections. They have disgusting for something. So it's not about only sentiments, positive or negative. It's about also expressing feelings about something. So you can have, for the same project, analyzing people's sentiments and emotions. So sentiments is about only positive or negative, and emotions is about having more than one type of feelings: sadness, anger, fear, disgust, surprise, love, hate. So what is the motivation? As we said, millions of users post their opinions about everything these days on internet, everything. So a few like microblogging websites nowadays are affecting people. So if you want to affect people, you need to learn how to understand data in internet. So this is what actually I feel like they are doing, like Elon Musk's and Mac and Mark and all of them. So they are all trying to analyze data. So the one that who control the data on internet is the one that who's gonna control actually everything. So whenever we need to make decisions, like usually if you wanna go for shopping, you wanna like try to Google it on internet and see the reviews of people, what are people talking about. If you wanna even vote for someone, you always Google it and try to see what this one has done and what this has done not doing. And even for the company themselves, if they want to sell you their camera or there's something, like they want to know what's your feedback about it so they can fix it later on. So it's all about text. They want to know your feelings, your sentiments about things. So this is the motivations of doing this study. So you can use text classification for political science. You can do it for marketing, for economic, for health. You can do this research for any type of fields in your study. So understanding the emotional contents of text can provide valuable insight about users or the contents. This is what we have talking about, like about voters, about customer feedback, reviews. Yeah, there's a study on 2020 for US election when they try to figure out before ahead which state in the US is gonna vote for Donald Trump or against Donald Trump. So yeah, people are doing this for every election in the US. They try to figure out in ahead, like even if they are not going to vote, or they want to know like which one who's gonna win in the future, so they can be friend for him. Like, okay, so if they know that Donald Trump is gonna be the winner at the end, they want to be like from now be friend for, and pay for his campaign. And so so this is how they do it. Like they collect people's tweets or data from everywhere and trying to figure out, like, for every state of the US, if they are talking about Donald Trump or Biden, and if they are talking about Donald Trump in positive way or negative way, or even for also for Biden, and how many times like have been mentioned for Donald Trump or Hillary Clinton or Biden. So from this, like, they will have small prediction who gonna win at the end. I had a small study about this, like in 2016. So what I have done is, like, for before Biden start working on his campaign, you know, like there's a debate for, like, all the presidents are standing in front of all the people and they ask them questions. So every president or every candidate will talk about his future things he's gonna do. So for every debate, I collect all the data, like 1 million tweets for every debate. So I would to know if they are with or against Donald Trump. So I only have hashtags, like collect the hashtags for Donald Trump, Trump like Hillary Clinton at that time, all the keywords, and found out that people are really, even if they are laughing on Donald Trump sometimes or something, but they are really with Donald Trump. For many reasons, like sometimes they hate Hillary Clinton for some reasons, or maybe at that time for that tweets, like they have some or he really gave good jokes. So sometimes even if you are giving good jokes, you will make people talk about you, and if people talk about you, you will be mentioned more. You will make people feel that you will win. So yeah, I think he has a good people supporting him at that time, and they played it very well. So detecting emotions in text. What I have worked on my research, on my PhD and all my work. So I have tweets, and from these tweets, I try to figure out if the tweets is about joy or sad or anger, fear. So there's a lot of public tweets on internet, and there's a lot of public data sets on internet. I usually use semi-eval competitions for that, Kaggle. So if you are, for me, I work as a pure computer science. I don't have a team for psychology or for political science or something. So I use public data to compete with others and to get better models for classifying text. So yeah, so for that, I used semi-eval competitions. So as I said, if you want to work on this field, you need to have some knowledge about machine learning, some knowledge about natural language processing, and you need to have a good background about cognitive science on your field. So if you're gonna work on politics, you need to have you need to know how people think as a political. Or if you are gonna work on health, you need to have someone in your group who's working on health. And if you want to work on economic and so on. So you need to have a good team for some people like working on natural language processing, NLP, or machine learning and cognitive science. So what is cognitive science? It is the interdisciplinary scientific investigations of the mind and intelligence. It's about how people think, okay, about something. So it's like combines philosophy, neuroscience, linguistics, psychology. So I had a study with one of my students to study people emotions for depression. So the first study on depressions for Arabic language was with my students Bara Batayne. So what we have done with Dr. Rihab, me, and Bara Batayne, like we have collected all the tweets with depressed. So we have some keywords about my mood is not good. I don't feel like I want to eat. I want to sleep more. I don't like this life. All these kind of keywords. And we asked for 5 people in psychology to help us to understand these tweets. To which level of that these tweets are depressed or not. So we want to know if people are gonna commit suicide or something, or they are really sad. So we have contact these people and ask them their permissions also, and ask them to which level they feel that they are sad. And also we contact the psychology doctors for them and ask their permissions to give us their permissions also if they are okay with handling these tweets. So yeah, for that we need third party. Okay, we cannot work alone. Machine learning, it's like a technology to teach computers how to think. So we know how human thinks. We need our computers to think like a human. This is machine learning. So you don't give instructions only to computers to do this and do that. It's not only programming, like you're gonna say if you have 1 and 2, the multiplying them will be like 2. No, it's about teaching your computer how to think like a human. So what we do with machine learning, if you have a bunch of photos about cats and dogs, you will feed your computer with all these photos, and then eventually the computer will learn if this photo is for dogs or for cats. This is how we teach our kids to differentiate between dog, cat, rabbit, and so on. You give them a bunch of photos and you say, like, this is cat, this is dog, this is cat, this is cat, this is dog. What is this? He will answer you eventually that this is dog or cat. And once he had wrong answer, you will say, no, this is cat, not dog. And so on. So this is how we do with machine learning. We don't say that if you see brown, this is cat, or if you see it as it is black, it is dog. No, you will say, you will show these photos to kids or to your computer here, and eventually your computer will learn how to differentiate between dogs and cats. Now we go with natural language processing. It is a field that need to know more about how to deal with linguistics and with machine learning. Okay, so we can apply this type of knowledge to cognitive science. So the field of study that focuses on the interaction between human language and computers is called natural language processing. Yeah, for short, we call it NLP. It is important to know something here about NLP. So, like 5 years ago, I believe, if I want to work on, let's say, on German language, I need to have someone with me speaks Germany, so we can handle these tweets or this data. If I work on Arabic language, I need someone who with me like speak in Arabic and handle this data. Nowadays, you don't need this, like, so you can handle Chinese language by yourself without even without any need for Chinese, like someone who speaks Chinese. So why? Because of deep learning. So we will talk about this later on, but still linguistics is very important. If you're gonna apply machine learning, you need linguistics very well. So you need like to know what are the stop words in your sentence in English or in Arabic or in Turkish or in Swedish, or so you need to know the stop words in this language. You need to know what are the articles, what are the plural and singular for every word, and so on. But with deep learning, you will find out that you don't need that. Anyway, so text classification workflow. So what we have talked about so far is what do I need to get into this? I need to know machine learning. I need to have someone with me to at least annotate these tweets. So I need someone to annotate these tweets for me for psychology, or for if I want to say that this tweet is fake or not fake. So if you are working on fake news or propaganda, or you need to talk about if this news on COVID-19 is fake or not fake, you need someone in health to know about this. So we have file of data. You will read it as like Gisam told us, show us before. So you will read your data, you will read the tweets and the labels of the tweets. You will have tweet here, and you have, I don't know if I can show that here. So this is the laser, I think. Is it like, yeah. Yeah, I mean, yeah, okay. Okay, anyway, yeah. And even for the cursor here also it's not working, so it's okay. It's like, just like to know that you have your tweets or your text and you have a label for that. This is supervised learning. For supervised learning, you need to know that you need someone to annotate this tweet for you. Actually, doing the annotation is really one of like the hardest part of your project. I know that. I don't know how many of you worked on data for text as a text and these tweets or annotated data. Yeah, usually what I do with my students is I give them, let's say, like 1 cent for each tweet. So if I give them 1,000 tweet, I will give them like $1 at the end. So yeah, because of the fun. And actually, this is how Amazon Turk is doing. So yeah, you can put all your tweets on Amazon Turk and ask people to annotate the tweets for you. So yeah, so like I have, let's say, tweets or that or text or images, and I ask my students in the class, if you need money, come to me in my office and I will tell you how to earn some money. So yeah, we need some people like to annotate this tweet. Why I need people to annotate this tweet for me? Because I don't want to be biased. So if this tweet, I feel maybe this tweet is joy, but for you, maybe you see like this is not joy. So I need 3 decisions for every tweet, or at least or maybe 5. For each tweet, I need 5 people to say that this is joy or anger. So and at the end, I will take the average for each tweet. So let's say for tweet number 1, 3 of you say that this is joy, 2 say that this is neutral. Yeah, at the average, like it is slightly joy. Okay. What if like 5 people say it is joy? Yeah, I will say that this is like it is degree of 3 as a joy. So I need bunch of people to say that this is joy or sad or anger. So to do annotations is really hard. So if like for students, it's like I can easily like ask them to do that for me. But if I want, let's say, political people to do that, yeah, I need to pay more. And if I need some, yeah. So this is like how we do it. Like if I wanna, so I work with data on let's say to find out if this image like X-ray has COVID or not. I need to ask doctors to do that for me, and we pay them very well. So we apply for fund in the university, and we ask these doctors to do that, to do the annotations, and we pay them for that. So to do the annotations is really one of the hardest part in your projects, in your research. Okay. Yes.
We need to calculate the interest the beginning for the student, for example, for not like the paper. For example, we say that we eliminate the tweet just under the, for example, 8%, something like that, or
yeah. So for tweets, it is public, first of all. So it is because of it's public and people know that it's public, so they know that the tweets will be taken. But it is always good for you to remove and mask the usernames, all usernames, to mask all the hashtags, to remove them before you publish them. So for your research work, I usually do that. I work with the data itself, but I don't publish them on GitHub or any resource unless if I do all the masking. So I remove all the usernames, I remove all the tags. Like if there is something like really, yeah, I remove that. So, but you don't need to take permissions for these people. I'm talking about, if I'm gonna talk about people who have some depressions and I want their like user profile, yeah, I need to take their permission. The IRP, yes, for sure. Yeah, you for every tweet. No. For Twitter, no, we don't do that because there is no IRP for that. So you are allowed to collect 500 tweets by yourself. So there is no IRP for that. But if you want to collect more, you need to ask Twitter organization. Actually, it happens this year or last year that you need to apply for Twitter themselves to collect more tweets about something. So what we do is like we collect the tweets, but I don't publish them. For me, I never publish these tweets. But if you're gonna publish that, make sure that you mask the Twitter ID. Yeah. What if like I wanna get other data, like let's say health data? Yeah, here I need an IRP from the hospital. I need to make sure that the team of the doctors make sure that there is no information about the patients there. The data is like belongs to the hospital itself. So the hospital gave me the permission to collect this data. Yes, we have the IRP with our hospital in the university, and we collect this data. But for the Twitter, no, there is no IRP for that. Until up to my knowledge, there is no IRP for that. Yes. Maybe it's up to you. I mean, like for annotations, there's many like techniques for that. So if what we do usually, if I have expert to do annotations, I think 2 is enough, and I will be the 3rd one. Okay, so if I say that I have 2 master students doing the annotations, I think they are both enough, and you need to mention that in your paper. Like, so you say like for annotations, we have 2 graduate students who do the annotations, and if there is no agreements between these, so we have the 3rd party, which is one of the researchers on this paper who do that, and you will mention that. But if like you say that you ask 5 people randomly to do the annotations, I think 5 is good also. So you will do the majority for that, and sometimes 5 is not enough. You need 10. So sometimes the majority, yes, yeah, or sometimes like you do some calculations and taking the average. Yeah, it's like it's up to you how you need the label. Is it like out of 10 the label, or it is a majority 0 or 1? So you wanna take it like as a majority, like 0 or 1. So it's maybe degree of like how is the level of the joy or the sadness in the tweets. So yes. Aywa, تفضل. Yes. Yeah. Exactly. So so we have worked, yeah. So as I said, like we have many types or techniques for annotations. One of the techniques that I also worked actually with the Gizam also. So we work on using a dictionary. So if this tweet has this types of words, it means anger. But this is not like sufficient enough. Okay. So to like like even if you say like this ice cream is cold, it is good. It just means joy. But what if I say this person is cold? I mean, I mean that he's not good. Yeah. So sometimes the word itself is not sufficient to say that this is a joy or anger or sad or negative, positive. So you need someone to judge this tweet for you. So to have annotators for you, it's better. But as I said, you need money to do the annotations. So yeah, the annotation is really one of the hard parts for your work. Okay, let's say that you and your advisors have managed to do the annotations. You have the data, you have 1 million tweets that you need to classify now, and you now to build your model. And once you build your model, you can publish it. So your model will be able to handle any tweet. Okay, so you need a sufficient amount of data, so you can show it to your computer, and he will, like the computer will learn eventually how to handle tweets. If it is like to know if it is joy or sad or anger tweets. Okay, so we need after that. Okay, so as I said, look, we need data. So one of the data that I worked on is to collect data from Twitter, but you can have data from Reddit, from Kaggle, from public data available for you. You can use whatever data you need to collect. Data cleaning. So for machine learning, you need to do a lot of cleaning for data. For machine learning, okay? Because for deep learning, you don't need this. Okay, mostly you don't need this. But for machine learning, yes. If I'm going to clean my data for German language, I need to have someone with me speak Germany very well. and know what are the stop words, what are like how to handle what is like the where's the spelling errors in this text and so on. So you need like maybe you need to eliminate stop words from your text, because stop words like why do I need to have the word the articles the and or if. So for these they have no emotions. These stop words has no emotions, so I don't need them. So I can eliminate them. Also removing Unicode, or removing numbers, or URL links, hashtags, and others. So one of the examples is here. Like if I say, hey Amazon, my package never arrived, and there's like a website here, and please fix as soon as possible, and let's say Amazon help. If like you can write a code as we saw with Gizem before this session, that you can clean this text by using like remove all the stop words, remove like lowercase your words, remove the URL links, hashtags, and it becomes like this. Amazon package never arrived, fix as soon as possible. So you will have like only small sentence here. And from this sentence, you will feed it to your machine language model. Okay. Computers doesn't understand numbers. This is very important to know. They doesn't understand text. So computers only understand numbers. So you cannot feed your text to your machine language model. You need to convert your text or your string into numbers, then feed it to machine learning. So how to convert text into numbers? This is one of the most important topics these days. And this is how Google and Facebook are doing really good with deep learning these days. And they are handling text very well, because they can convert text into numbers in a very good way. So the technique for converting text into numbers called text vectorizations. You are converting the whole text into vector or array of numbers. This is called text vectorization. You have, this is a sentence, and you're going to convert it into numbers. Okay, how to convert text into numbers? Before we understand this, and before we talk about this, because we're going to talk about this like deeply now, there are some terminology that we need to understand. So there's the word document for NLP people. Document means a sentence in your data. So if it is a tweet or a review, okay, so there's a document, which is a single text data point. Like here, I have document 1, 2, 3. It's not a whole file of documents. It is like a single sentence or statements or that is labeled to one of the types of emotions or something, or any label. There's also the word corpus. You will hear this a lot in NLP community. So what is corpus? It is like all your data in one file, or one big or couple of files. This is called corpus. So a collection of all documents. Like when I say documents, it means like the sentences of the documents, like the tweets, all the tweets in one big file, or maybe a couple of files. This is called corpus. So this is a corpus. Text 0, text 1, text 2, 3, and you can have label for them also if needed. There's also the word feature. Feature in machine learning is very important. So every record has a couple of features. Okay, so the tweet combines features. So how the tweet combine features? Every word in a tweet is a feature. Every word in a tweet is a feature. So the feature is like every unique word in the corpus is considered as a feature. So if I say like text 0, this is a brown home. Okay, this is a brown house. This house is big, no street numbers. So first of all, you will read this tweet or text or document, and then you're gonna tokenize it, like cut it into words. And then you need to convert the text into numbers. You will say that this tweet contains brown, so brown is 1, but doesn't contain red, so red is 0, and doesn't contain black, but so black 0, and so on. So at the end you will have 1 0 1 0 0 0 0 1 0 and so on. So for the tweet itself, you will have binary digits or maybe numbers for each tweet or for each document. We will see that later on. So these numbers are the features for you. These numbers are the features. So you will feed your machine learning model or your, let's say, computer with numbers. You will have a vector of numbers for every tweet. And these numbers are the features. So the word feature is very important to know. For text vectorization techniques, we have some popular methods like binary term frequency, bag of words term frequency, anagram vectorizations, TF-IDF term frequency, and inverse document frequency, TF-IDF. So I will talk about them all now, and like what do we mean by this terminology? And tomorrow we will apply some of them. Okay, so you're gonna tomorrow work on coding, how to read a file and how to convert text into like numbers and apply machine learning on them. So today I will give you the theory about this, and then we will have the coding sessions tomorrow for that. Okay, so let's say I have these, this corpus, or these, let's say, texts. Let's call them like tweets or text or documents. These are like, we have 4 documents here in one corpus. So one of the ways that I do that is like a binary term frequency. For binary term frequency, as you can see here, this is text 0, text 1, 2, 3, this is the ID. And then I will put all the dictionary as columns here. All my dictionary is here after removing all the stop words. So I removed all the stop words. So I removed this, is, app. These are all have been removed. So I will say that text 0 has no number 12, so it's 0. It doesn't have the word include, so it's 0. It has the word big. How to have the word go, it has the word pass, it has the vice, and so on. So text is 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 0. This is how I identify my new text now. It is not, this is a brown house, this house is big, no street number, no. For me now, it is 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1. The same for text number 1. No, you should have, for term frequency, you should have all the words. So if if you have a big document, or let's say that you have Wikipedia, you will have 10,000 columns.
But not on the area.
In the distance, yeah, maybe, yeah, exactly. And if you have, like, let's say, you have the data of like, let's say, 1 million tweets, you will have more than 10,000 words. So yeah, you will have, as you're gonna imagine, that you will have a lot of zeros here, and that's why they call it sparse matrix. What does it mean, sparse? A lot of zeros in your matrix, which is not good. Which is not good. Yes.
As far as I understand that, based on the vectorization method, you clean your data on that.
Yes. Yeah. Actually, yes. So maybe you will not. So for me, in my data for Donald Trump, I moved the word Donald and the word Trump, because it will be like every tweet, the word Donald and Trump. So yes, it's not only you remove the articles or the numbers, it's up to your research one.
I mean that a lot is bad.
We don't need it.
That the vectorization actually fits fine.
Exactly.
Or not.
Exactly. So your question is really advanced, but like it's really a nice, a very good question. So as I said, for deep learning, nowadays I don't do that. But these are the old methods at the beginning. So if you're gonna work on with machine learning step by step, you need to know what have been done before, and then go to the advanced topics. So for now, if you're gonna do this and apply it to your study for political study, you will get a good results for that, but you will not be able to compete with Google or Facebook. Okay, so you will have a good paper to publish using the term frequency and the FIDF, but you will not be able to compete with Facebook and Google because they are using now deep learning models like PERT and Roberta models. So the term frequency will do a good for small research projects or assignments. Okay, yes. Yeah, you need to do that by yourself. So yeah, it's like it's either you will make a dictionary for other English words that if this word is not in this dictionary, remove it. Which is like sometimes people like try to write things like in a very, like, let's say, funny way. Let's say that they say like the word thanks, THX, or maybe they say wow, or maybe they say wow like WOOOOOW. So you don't want to remove this because it has emotions in these words. So sometimes you have to remove them. But with deep learning, as I said, there's no need to remove anything because all these will be like really conveyed very well in your tweets, and you can handle that in your models. So for machine learning, yes, you need sometimes like your models is not gonna it's not gonna be comparable at all with deep learning. Yes. Other question. Yes. Yeah, I put it in my dictionary. So I will have a file that has all the stop words I need to remove, and I will add the word Trump also with it, or maybe the word Clinton and so on. So I will add it to the my stop words. So once I will program it as a for loop in my code. Once I see the word Trump, remove it. So yes. Yeah, the TFIDF do that for us. Yeah, good, yeah. So yeah, you can do it automatically also. If a word happens to be like frequent, yes, you can remove it. Yeah, you can have this also as a parameter. If the word happens a lot, you can remove it. Yes. If there is no full stop?
Yeah, in this sentence. There is lots of sentences, but there is no full stop.
So yeah, you will have like, so your question is like what I'm gonna do with a sentence that has no full stop. So for text, there's you mean like if I have a big document? Yeah, you need to have some way or technique to cut the sentences in, like if there is like. Okay. Exactly. So one of the techniques is like to have max length for your text. So if your, let's say your documents has like 1,000 words, you will say that my max length is 100. So once, like for the first 100, I will put it in my model, and the rest I will padding it, like I remove it. Or it's, I mean, at the end, it's up to the researcher how he can handle. So there is no like one rule for every research, but yes, you need to read about how people do that and what is the good technique for this or that. Any question? Okay. Should be like alphabetically ordered. Alphabetically ordered, yes. You need to order the text here, so all the text will be that I will know that this 0 means this word. So this should be like alphabetically ordered, yes. So exactly. So yeah, this is like one of the drawback. Yeah. Yeah, this is what they call it, yeah, bag of words. Yeah. Nice. This is good. So yeah, this is why they call it bag of words. So you have a bag of words, and like you have like a bunch of words for every tweet. And this is why we say that this bag of words is a good technique at the beginning, but it still doesn't, like you cannot have the meaning of the words. So the word called, if it appears on the sentence, doesn't mean it is positive or negative, because you don't know if the word called came with ice cream or it came with person. So yeah. So this is what we call bag of words, term frequency. Like this is an example of that. As we said, the drawback of that is the order of occurrence of words is lost. So we will, because we're gonna arrange all the words in alphabetically order in our columns, so we will lose the order of the occurrence. The anagram vectorizations similar to also to the bag of words technique, but in this time I will not give 1 or 0 for every word. I will say, like, let's say I will have 2 grams. So anagrams means like, yeah, you can combine every 2 words together, or every 3 words together, or every 4 words together. So with anagram, you will say that if I say that I have anagram 2, or let's say in this example, I'm going to talk about this example. So if I have this sentence, I am studying NLP. If n equal 2, then I will take every 2 words together. So I will give it 1 or 0, and I will put column for every word and other column for every 2 words. So I will have more features. So if I have 10,000 words, I will also have other like 10,000 also, or maybe 20,000 words or fields for that. Can you imagine how many zeros I will have in my table? Yeah, this is why we call it as sparse vector. So for anagram, or like bigram here, for 2 grams, or for trigram if we have 3 grams and 4 grams. So for every 2 words, like let's say if I have n equal to, then I will have vector for I am studying NLP. So this tweet, I am studying NLP, you will have zeros and ones for them, and also zeros and ones for these n-grams. It is also a good technique, but it's also old-fashioned now. But it's still, you will have a lot of papers. You can read them like in 2022 that use anagrams for that. So why anagram vectorizations? It is considered a one way to enrich the representation of your features. So you will have more features also. The intuitions here is that bigrams and trigrams can capture the contextual information compared to just unigrams. For example, having the word good food is better than having the word good alone and food alone. Okay, so good food is is a positive word, but good alone and food alone is not, like you cannot tell. Again, drawback, we will have a huge sparse matrix. And the more matrix you have, the more that you need to handle it in your model, and it will take time, and you need to run it for a long time. So yeah, it's a huge sparse matrix. Now we will come to TF-IDF. It is really good for actually I use it a lot for SVM, support vector machine models. I use TF-IDF a lot, and still it's like really favorable for many researchers so far. So with TF-IDF, it stands for term frequency inverse document frequency. TF-IDF from so we're still talking about how I'm going to convert a text into vector. Okay, so I'm still talking about this. So TF-IDF is multiplying the term frequency of the term, multiplying by the IDF of the term. What is TF-IDF? So let's start with TF, term frequency. So for term frequency, you measure the frequency of a word in a document. I know that it's a lot of information here, but we will go next to the after this part to the model machine learning part. So yeah, let's give it more time for this topic here. I want to know, like, if I have a document of a tweet, and I want to count how many times the word, let's say, anger or happy happens in a tweet. So it's good to know the numbers of how many or how frequency the word happy appears in the tweet. So I am very happy about this workshop. This is a happy day for me. I love this workshop. And so you will have the word happy twice. It's better than having the word happy once. Okay, but it's not always the same, because let's say someone is like having 1,000, let's say, word talking about a hotel thing, and one is talking on only, another one have like only one sentence talk about hotel. So this one who's talking about the hotel in one sentence and mentioned happy once is means something more than the one that who have 1,000 words in his, like, talking about a hotel, and he mentioned happy twice only. Because you need to take the frequency or like frequency of the word happy, like compared to the whole sentence in your conversation. So for term frequency, we perform normalizations here to say that the word happy happens twice above 1,000 words, while the word happy with the second person happens once above 10 words. So 1/10 is better than 2/1,000. So term frequency is the number of times term appears in a document, the number of terms in documents. Actually, this is all computed by Python using packages. You don't need to do the whole calculation. Just like import the package TF-IDF or vectorizer, and it will do the whole calculation for you. Yes. Yes. Yeah. So it will like for every term. Yes, for every term, you will compute how many times this term happens in this document, and above overall the number of words in this document. Exactly. Yes, yes, for every them. So I'm gonna show you an example here. Okay, let me show you this here. So as you see here, I have the word I have the 4 documents. Document 1, 2, 3, 4. So I have sky blue, sun bright day, sun sky bright, can see shining sun, bright sun. So these are the documents after I remove the stop words. So maybe the first one was the sky is blue. The sky is blue. I removed that and is, so I only have sky blue. So the term frequency, I will compute the term frequency for every word. For the word sky, for the word blue. So as you can see here, I only have blue, and I only have sky. This one is white. Okay, but the term frequency, as I said here, it will be of 1 over how many words in the first frequency? So 1 over 2 and 1 over 2. Let's take as an example the second one, sequence 2, sun, or let's say sequence 4. So it has more sun here. Okay, so for sequence 4, I have the word bright, can, see, shining, and 2 sun. Okay, so I have 6 words. The word bright happens 1 over 6. The word can happens 1 over 6. 1 over 6. 1 over 6. 2 over 6. There'll be 1 over 3. How I compute the term frequency. Okay? It's like this is how I compute the term frequency for my tweets. This is a TF. Now we will go to the IDF. Now we will go to the IDF. Okay. So for IDF, before I go with the inverse document frequency, I need to understand what is document frequency. I need to know how many times the word appears in all documents. So maybe the word, as I said, the word Trump, if it appears in all documents, it's not important for me. The word Trump, if it appears in all documents, it's not important for me. Why? Because like it doesn't have any, I cannot like say that this tweet is good or not if it has the word Trump, because it happens in all tweets. So the DF or the IDF for this tweet, for this word is gonna be 0. So it's better for me to remove this word. So what is document frequency is limitations of the importance of the word in the documents. So the IDF is total number of documents that I have. Let's say I have 10 documents and the word Trump have happened in all the documents. So the log of 10 over 10 is 0. Okay. So if a word happens in all documents, it's not important for me. Okay. Again, if like so the article, the stop words can be removed easily, automatically, without any need from me to do that. So this is how I can answer her questions when she asked me if there's an automatic way to remove the word Trump without adding it to my stop words. Yes, by using the IDF. So if the IDF is very low, remove it. It means that the word is not important. Okay. Sometimes it's 0. If it happens in all documents, if it happens in one document, also it's not that good. I mean, like, doesn't mean anything if it happens in only 1 or 2 documents. It's going to be like a very rare word that is not that important. So sometimes you remove the word that happens frequently in all documents, or it happens once or twice in one of the documents. So the TF-IDF really is a good way. This is how we do the IDF. And this is the whole example. So the same examples. We have the TF here. We would have the IDF there. As you can see, the word blue is very important. The word, like let's say, the word bright is not that important because it's almost happened in all these sentences. As you see, D2 has bright, D3 has bright, D4 has bright. So it's nothing that important. But the word blue, it has higher importance, as you can see here, 0.6. Can you? Okay. So 0.6. It's more important than bright. Why? Because it happens only once. So what I'm going to do with TF-IDF is multiplying blue with blue. So we have this. And for bright, 0 divided by 0.125, still 0. So it is the TF is 0, it will be 0. And if the IDF is 0, it will be 0. So you will have more meaning for the words now. And the numbers means that this word is important or not important. So TF-IDF is better than term frequency alone or bag of word alone. Okay? And it's good for machine learning. And we will learn, I think we will learn that tomorrow. If we had time for that, we can complete that together. So this is another example. So, but still sparse matrix. It is still a sparse matrix. Oh, when I say sparse, I mean a lot of zeros in your matrix here. Okay, this is the drawback. Still sparse. Okay. Now, yeah, here. TF-IDF, yes.
And I need to use a threshold to eliminate some code, but I don't know which threshold I should be. When I search the literature, I
Exactly, yeah.
well known or well accepted threshold for that. I don't know how to define my TF-IDF threshold for any judging.
That's really a good question. Let me tell you about her question before I answer her. So for machine learning and for our coding with Python, we have the TF-IDF ready to be used. So you only put or play with the numbers in your package. So you will import the package. You will have TF-IDF ready for you. Just say apply TF-IDF, okay, as a vectorizer, and you say like remove all the words that have IDF 0, or it has IDF less than 0.001, or more than 0. Whatever. Okay, so you can only play with the threshold. So she's asking how I know what is the threshold that is really good for my research. Actually, there is no rule for that. You need to read and apply and doing the fine tuning for that in your research to find a best or the better accuracy for your work. So I cannot answer like so. Usually people are doing like to say start with a good base number for that, and then you will play with these numbers. So you will like raise your threshold or lower your threshold. So you will keep doing this until you find the best threshold for your model. There is no answer for that. Like no one's gonna answer you for this because it's all about like trial and error in machine learning.
There is no value, for example. There are many that then I conduct my topic modeling, then there is too much work. It's not very hard for me to label that topic so that I need to
Yes.
threshold. So that I don't know. Of course, I tried, but I don't know how to find.
Yeah, you will start with a number, like let's say like 0.3, and then you will raise it a little bit and see how the accuracy is and how the topics are changing or not, and how when you are lowering the threshold, you will see how is your models going on. So this is how we do the research with machine learning. Yeah, it's different between like it's different than doing research with let's say programming, solving problems. So when you solve problems, you will say that if I multiply x by y and dividing it with z, I will have this answer. So that's it. So this will answer my question. But with machine learning, no, you will always like play with the numbers until you find a good balance between, let's say, precision and recall, to find a good accuracy in your model. Yeah, even for unsupervised, yes, you will try to find that like if the topics are really relevant to your projects or not. Yeah, you will always like try to with trial and error. And this is my answer. If anyone has another answer, it's well, I will be happy to answer.
Okay, can calculate the accuracy. Okay, but you are conducting unsupervised one.
It's like it's you need to have a third party for you, like with you, like to look at your work. Say like you are working on vertical science, so you will have some vertical people with you to see that this is the topics that are really making sense for me, that these are topics like that is people talking about these days and or not. Or so it's about trial and error for machine learning, and even for supervised or unsupervised learning. Okay. So for now, this part is a little bit about deep learning. Okay, this is still we are talking about how to convert text into numbers, but now we are talking about the new techniques of Google and Facebook people, how they handle and how they convert text into numbers. They do that by using word embeddings. This is really like blowing techniques in the world of NLP. They don't use TF-IDF, not term frequency. They are using dense vector representation. What they are doing, like to make the story short, what they are doing is like they are taking all the Wikipedia, let's say, and all the Twitter data and Facebook, and try to figure out how this word come with this word. Okay, so the word new with the word York, New York, it is one word. And if it is ice with the cream, like it will be like always like coming together. So icy cream will have different meanings than ice. Let's say ice man or ice heart or cold heart. Or so if this word come with this word, it means something. So it's gonna be like in one dimensions or another dimensions and so on. So it's gonna be like vector representation. When we say vector representation here, we have like dimensions of your life or of everything here, and you will have these words as a vector with data. Okay, so it's a vector with numbers, and we will see that the words that are similar to each other clusters together. Okay, so what Google have done is like they took all the data from Wikipedia and try to build a very huge vector or word embeddings model, and they give it to us. So they gave us PERT models that is ready for use. You will have vector for all the text, for all the words for you. You don't need to do the TF-IDF. You don't need to use the term frequency. You just like import PERT models or PERT models and apply these word embeddings to your project. And believe me, even if you try TF-IDF with your work, and if you are competing with others, you will see always that word embeddings really doing better than any other vectorization techniques. For my students and for my work, yeah, we always have this. We always have that word embeddings is doing way better than other vectorization technique. So I don't know. Okay, yeah, I think we don't have much time, so I will talk about this. So as we said, we have a sparse vector. We have a sparse vector for the words that we have here. But if you try, let's say, if I say that every student has grades, okay, for math, for physics, for chemical, for biology, for Arabic, for English, for Turkish, for every subject, and then I wanna give every student only 3 grades that identify the students. I will choose that every student should have some grades for scientific fields or literature fields and say humanity fields. So what I'm gonna do is I will try to do a good equation for physics plus chemistry plus biology plus mathematics and do something like for them with do averaging and give them a grade for the students. So I know that this student is 90% scientific. Okay, so he has a good scientific knowledge, 90%, but it doesn't mean that he has 90 for physics or chemistry or biology or mathematics. It's just like I did some computations for that. So instead of having 20 fields for each student, I will only have 3 fields. I will do some aggregations for his scientific knowledge, for his, let's say, literatures and linguistic knowledge, and for his humanity art knowledge. So this is what we have done here. For the words with, let's say, with Google and Facebook, and what they have done is like they try to give every word less dimensions. Instead of having 10,000 dimensions, I will compress them to only 300 dimensions. And when I say only 300, this is really good to have only 300 dimensions. So you will not have zeros now. You will have more combined and more dense vector. So you will have less zeros. And that means that for every word, there's only 300 dimensions for every word. And this is how we can know that this word, the word ice cream and the word ice, let's say Iceman or ice mountain, or it different than each other, because now the word, when the word ice come with the cream, it means that it is something positive. And if it come with, let's say, ice weather, it came like with more negative, and so on. So we will have more dense vectorizations here. I tried to apply this in my, in 2014 or 15. I tried to have a good data for me and trying to do my own vectorizations techniques, but I will never be able to compete with Google. So Google, what they have done is like they took all the Wikipedia data and all the data from I think from Wikipedia, from Facebook, from Twitter, and they try to have good embeddings for the words. So they have embeddings for all the languages. So I don't need to know Chinese to work with Chinese model. I have the embeddings for Chinese language. Just like download Chinese BERT and to work for you. Download Turkish BERT and it works for you. So you will have these embeddings ready for use. You just need to tweak these embeddings, okay? Yeah, this is a comparison. So now, as you see here, the word man and the word king, they only have small difference, 001 and 002. You will have like 3 different, instead of having columns for the man or the woman and boy and girl, you will have like, you will try to make dense vector here. So for every dimension, it means something. You don't need to know the meaning of this dimension, but this is only an example for you. So what they have done is like they try once, like, I mean, they tried to have 300 dimensions or 500 dimensions, or maybe 1,200, until they found that 300 is really good for their dimensions. But for PERT, they have 1,024, I think, dimensions for every word. When I say dimension, it's like, it's good that for every word, only 1,000 dimension. As I said, with term frequency, you will have 10,000 dimension, 10,000 feature. But with PERT, Ruperta, and word embeddings, you will have compress vector. So now your vector is compressed, less zeros here in your data, and you will have like the words that are similar together, okay, clustered together. This is word embeddings. As I said, like this is the new techniques for converting text into numbers, is using word embeddings. And you need to import package called Hugging Face to import these embeddings or word embeddings for your research. Okay. I will jump to this part here. So, as we said, we have tweets and label for the tweet. We clean the text if we need to clean the text, and we need to convert the text into features. So we have features. So far, text have been converted into numbers. Now we will build our model. As I said, here this lecture is not about building the model itself. We will leave this to next sessions or for next day's sessions. But you need to know that you have the labels, you have the tweet, you have the number, but you have converted all tweets into numbers using kilograms, bygrams, whatever you have used, and you have the labels. And now you have your feature matrix. It's like a matrix of numbers, and you will apply it to a machine learning model. After you have one model to predict the tweets, now you will try to predict new tweets. So for the new tweets, you put the scale, you will convert the tweets into numbers and try to apply it to your model to find out if the tweet has joy or not. So what you usually do is you will have, let's say, 1 million tweet. You will have 700,000 for training, to train your model, and you will leave 300,000 for testing. We have questions? Yes, please. Many thanks. I just wondered whether we can represent these spots as matrix multiplications in order to reduce dimensions. Is this an existing technique? Matrix multiplication. So like this is how we do the TF-IDF RDIM. So we do that like with multiplying the term frequency with IDF. So yeah, the matrix multiplication is used here for but not for reducing dimensions. For the LDA and I think I don't know, like the other word, the SPA, I think it's like the LDA. So you can reduce your dimensions by doing some multiplications for the rows and the columns. Yeah, for these columns. So yes, yeah, there are chapters in machine learning books that I can give it to you after this lectures that talk about how to reduce and how to do dimension reductions. So it's like a whole field to how to reduce dimensions in your data. So yes, we should have like there's a lot of talk about this topic. Okay, I hope like I answered your questions. Heard them. Okay. Thank you. Okay. So as I said, if you have 1 million tweets, you will have 700 for training, and you will have the labels for the 300 not to be trained, like just for testing, just to say that I will do my model and I will apply only 700 for my model. And after I have done, I finish my models and make sure that model is good, I will test my model. If it is good, I will publish it, I will sell it. If it's not good, I will keep working on my training only alone. So I don't play with the testing. what people do sometimes is that they put the whole 1 million in their model, and they train the data. Then they will choose randomly, let's say 10 or 5 or let's say 10,000 tweets randomly from the training, and they test that, and they say, oh, we have 100% accuracy. This is wrong. The testing should be hidden. Okay, don't play with the test. Only take the training, play with the training, do the whole training on the training data sets alone, and just to see how good is your model, you will apply it to your test data. So this is what we call it generalization. I need to know that my model is good, is having an appropriate fit. Not too good, because if it is 100%, it means that you have very bad model. If it is 100% accuracy, because like you will never have 100 accuracy for model unless if you have like playing or cheating or something. So yeah, the 100% accuracy is not good for your model. And sometimes I feel like my students trying to say, my model is 100%. Why did you reduce my grades? I say, yeah, you have trained all your data, and then you tested on the same data by itself. So it is 100% accuracy. So and if you have, like, let's say 70% or 60% accuracy, it's also not good. Sometimes I say, I have 60%, but it is good. I say, yeah, it's maybe you are working on a very difficult topic, and having 60% accuracy is really good. So it's up to your research. Maybe 90% is good for you, or maybe 95 is good, and maybe so it's up to your research work. Okay, so in medicine, 90% is not good. For medical fields, it's not good to have 90%. You need to have like 98% to say that your model is good or not for some topics. So you have some evaluation metrics to decide accuracy, precision, recall, and upon score. I will not talk about these, but like this is how we evaluate our model. Text classification approaches. Like we have many classifiers to talk about. As I said, we will not talk about these today. Just like you need to choose one of these models and apply it to your model, to your data. You may apply SVM, support machine, base, deep learning, machine learning, CNN, machine networks, recurrent neural networks, and so on. This is an example. Like I have these tweets, and I will apply some. So this is the code. So as I just want to show you, like so the whole slides are on GitHub, so you can have the whole slides and read it later on. But I want to tell you that how the code is really easy. Like the whole thing that we have talking about here is like it's just like you need to only import packages. So you will apply all these together. Okay, so you will from scikit-learn, you will import existing splits. You will extract features by using counter vectorizer, which is it's the PFIDF version of counter vectorizers. You will read your data or your file. You will have fairly existing splits. This is all like 1 or 2 sentences. And by using counter vectorizers, you will convert your text into numbers, and then by using scikit-learn, you can import base or SVM or deep learning models and apply it and do the fit. Fit means that train your model, and then you will have model score. So this is a whole code for that. Like you will read your text fine, you will have training and testing, you will convert the training and testing into numbers, and apply the whole models on that and having score. So is this a good for research? For this point, yeah, it's good, but like you need to work more on this to have better accuracy. For deep learning approach, as I said, it is really one of the advanced topics. these days. And if you want to go with publishing your work for your PhD or master thesis, you need to go or a little bit like read more about deep learning, because if one of your committee members is computer scientist, he will ask you why you didn't apply deep learning, why you didn't apply this. And even if you try to publish your work in a computer science department or a computer science journal, they will ask you why you didn't apply deep learning, why you didn't apply this. So at least you need to read about that, and so you can answer them in your defense or in your yes. I cannot hear you.
Is there a
Is there
reason why you would not have people? So how could we answer the question? If we could be on, why would we not?
So yeah, if you, I mean, like, what happens these days? Like, actually, I have a friend. She have done her PhD with computer visions with machine learning. Okay, so in 2016, and she's trying to publish her paper, and all papers are rejected for computer visions because she's only doing machine learning. She's not doing deep learning. And once she's trying to submit her paper to journals with medical environments, and they are saying, why you didn't apply deep learning on this? So she shouldn't have an answer for that. So she's now working on her dissertation again after she defended her work, just to apply deep learning on her work. So sometimes, yeah, these days, like, deep learning is really important these days. So if you need like, yeah, you need at least like to know a little bit or read more about this topic. Yes.
I think it can be another reason if you talk about the trade-off. For instance, if we have small amount of data, then machine learning would be the better.
Exactly.
You don't need to go through all the costs. If you compare the trade-off between the resources, the computation, and the amount of data or the you can get your answer. Either you should do learning or
yes. Yeah, one of my answers is like, I don't have enough GPUs, or maybe I don't have enough data for applying deep learning. Yes, so this is why you need at least to know the answers for your committee to answer them why you didn't apply deep learning for that or this. So I have only small amount of data, let's say, for example. But these days, like, even transfer learning is doing a great job with deep learning more than machine learning. So like, as I said, the new versions of work these days is all about deep learning and the word embedding. So as you can see, everything nowadays is like from 2018 and more, it's about word embeddings, and it's about like with Google and Facebook and all this stuff is about deep learning and applying transfer learning with vectorizations. So yes, you need to read more about how to do embeddings. So these are like, these packages are ready to be used in Python. You can easily apply them if you open tutorials for that. Yes. Yes. Yeah, for me, I usually do TF-IDF for SVM, okay, and I do like word embeddings, GLOV or words to Vic with LSTM. Like, I usually do that. Like 2018. Now I always do PERT. So, but for 2018, I used like to do TF-IDF with SVM. Okay, so it gave me a good like results for using TF-IDF with SVM supported to machine, and used with LSTM and by LSTM and GRUs I used word embeddings, word to Vic, tweet to Vic, glove. So there's a lot of word embeddings. Just like you will have them all public on internet. Just like search for them. But yes, for LSTM and which is like deep learning, for LSTM here, for LSTM and by LSTM, this like here for LSTM by LSTM, these you can use word embeddings with. And for the base and SVM trees, you can use TF-IDF for them. So actually, you can use any vector of numbers with these algorithms. It's about accuracy and about your performance of your model. If it's not doing good, why you need it? Okay. So sometimes like you follow what people do. So if you know that someone worked TF-IDF with SVM, do because he successed with that and he published that and he talked about that. So yes.
Do these models work well on texts that are not very I study complications of code deflection, which uses whether like specific terminology and the way they
nice question.
Are, a little bit different than the right?
Yes.
How would these models still work well, or
for any questions you have, like you will see that there's someone before you think about that, and he published already data for that. So you will see that on internet that there is a PERT for medical knowledge or terminology. There is PERT, which is word embeddings. Word embeddings for only engineering, for political people, for Turkish, for Swedish, for Germany, for Arabic, for Quranic written. So you will see that every researcher's doing that. Like he will collect tweets or data with terminology and publish that and say that I have done this. But as I said, Google and Facebook have done all this for us. It's ready for us. Just import Hugging Face and work on that. Let me show that. Yeah. So this is deep learning. So you can use deep learning for that. If it is very expensive for you, good news is Google and Facebook have done all of that for us. So there's something called transfer learning. You only import PERT and Roberta that are ready to be used. So instead of so you will have let's say PERT have been trained on a big source of data. Okay, you will transfer the knowledge for your small data. So if you have your small, let's say 1 million tweets of political, let's say about Ukraine and Russia war, just import the PERT of the whole Google thing, okay, and do some fine tuning with the parameters to apply for your small data and for your small research. So Andrew and G said the transfer learning and the word embeddings is like the next important thing for after supervised learning. So we need to this is PERT and PERT and Perny. This is how they named their models. So they have Elmo model, PERT model because of the SimSimi thing. So PERT, Elmo, Perny. PERT and Roberta have been PERT have been came to us in 2018, Roberta in 2019, Roberta for Facebook, PERT for Google. So we will not be able to compete with Google and Facebook. Let's say that. So use them wisely, and do your research with that. So only install transformers and apply them for your model. This is the theory thing about text classifications. This is the advanced topics. So I'm talking about what have been done lately for 2022. Okay, in computer with background computer science background. So if you need to work, you need to start with what have been done lately and start from that point. If you say like, so what I can do with my research? Yeah, you still have a big window for your research to collect tweets or collect data and to annotate that data and to have experts to do the whole annotations is really a big part of your research. Applying a good embedding models and build a model and publish that is still a good work, and having good conclusions about what is your findings of this research is still a big thing in your research. So this is the end of this is one of the research work I have done. So as you see, one of the work we have done, we try many things. We try to use a lot of embedding, which is word embedding, emojis, and we tried active tweet packages from for dictionary, and with using by LSTM, and we tried the data itself without any cleaning the raw data and with curved, and we tried to combine these results to build one model that can predict the emotions for these tweets. So sometimes you need to apply a lot. So not only one model, not only 2 models, 3, 4. You need to have a lot of models and combine them. This is what we call them ensemble model. You are ensembling different models together to get one good prediction. So, yeah, these are good resources to references if you want to know more about machine and deep learning and neural networks. This I really follow this. He's really a good teacher, and he's really teaching machine learning and neural networks in a very good way. I know that I took more than my time. I'm sorry for that. So I know. Sorry for that. Sorry for being late. And if you have any question, please email me with that. Okay, Andrea.